the 1.4 million kilometer lead. Every radio command NASA sends to Voyager 1 must target a void 1.4 million kilometers ahead of the spacecraft's last known position. At its current velocity of 17 kilometers per second, the probe covers more than 3 times the distance between the Earth and the Moon during the time it takes light to traverse the gap. By the time our signal arrives, the hardware has already vacated the coordinates it occupied when the technician pressed send. This creates a unique operational geometry where mission control is perpetually aiming at a ghost. This lag is not just a delay, it is a physical decoupling of command and effect. The 47-hour feedback loop. With the spacecraft currently 25.8 billion kilometers away, the round-trip light time now exceeds 47 hours. If an engineer transmits a corrective sequence on Monday morning, the confirmation bits will not reach the Canberra or Goldstone dishes until Wednesday. This latency turns mission management into a 2-day guessing game where every instruction must be perfectly serialized. NASA can no longer iterate on errors in the loop. They rely on onboard fault protection software designed with 1970s logic. If a command causes an unexpected power draw, the probe must autonomously decide which systems to sacrifice long before a human can intervene. These trade-offs are now driving a drastic rationing strategy for the remaining wattage, surviving on 22 watts. As of June 2026, Voyager 1 is operating on a total power budget that allows only 22 watts for its final 2 science instruments. NASA deactivated the low-energy charged particles experiment on April 17th to prevent an undervoltage shutdown during a routine roll maneuver. Throughout May and June, engineers have been running the Big Bang test on Voyager 2, a high-stakes power bus reconfiguration intended to bypass failing voltage regulators. If this software patch stabilizes the sister ship, the team will attempt the same logic on Voyager 1 in July. This is the engineering equivalent of keeping a hospital running on a single-car battery while the building drifts further away. This reality exposes the hard limit of deep space command architecture. The signal under the noise. The move toward a 24-hour one-way signal time is the physical threshold where mission control ceases to be an active operator and becomes a passive historian. Between the April instrument shutdown and the current Big Bang testing, we see a clear pivot from science gathering to emergency life support. The 1.4 million kilometer lead required for every transmission proves that the speed of light is the ultimate constraint on the command and control model used for the last 60 years. For operators, this means the future of deep space requires total spacecraft autonomy, as the distance eventually makes any ground-based intervention irrelevant. We are witnessing the transition from a remote-controlled probe to an independent, decaying object that happens to still be talking. The specific indicator of the mission's remaining viability will be the success or failure of the power swap sequence scheduled for next month. Subscribe for more